All right, welcome to your favorite class. It's Calc 1. My name is Ron Patton. Hope you're doing well. All right, this is one of my favorite classes. Honestly, the chain rule. I absolutely love chain rule. A lot of people get confused with it, but I absolutely love it because, and this is the goal of today's is really understanding how to take a derivative of a composition. I love composition. So you're taking something and you're nesting it within another function to make something unique or interesting. And you're uh, this is really just the practice of doing that. So recall that the composition of function f of x with a function g of x is equal to f of g of x. Okay, so it's like you're nesting things within each other. It's actually pretty neat whenever you do that because you get a totally new and unusual function. So like, for example, if I did f of g of x, where f of x is equal to x squared and g of x is equal to sine of x, then you'll get this composition where it's sine squared of x. And that's different than if it was g of f of x, because if you have g of f of x, then you're taking x squared and you're putting it within sine. So these two are not the same if you do f of g and g of f. So you get different unusual things whenever you do compositions. And you can have two, you can have three, you can have multiple ones. But it's pretty neat whenever you do that. All right. So how should we expect the derivative of g of x, if that is f of 2 of x, be related to f prime? Um, so one way to look at it is if you take a sine function. So what would you expect from that? So if you look at sine of x and sine of 2x, you've got different wavelengths here. And just the period is just half as much for the 2x. So we would hope that that would shrink. Okay, so that's what's really happening in this is that you're shrinking it by a factor of 2. Um, so that if you're looking at if that graph, the derivative of g of x at a value a, okay, if you take that sine, the top one, and reduce it, okay, shrink it, then it should give you exactly what you would expect. Um, so if you take, so the derivative of g of x is equal to the f of 2 of a. So it means that uh, with that shrinking of whatever that composite function is, you also have to take that derivative. Okay, but you want to take one at a time of what we're doing with that. Um, so yeah, so also if you take the g of x, then it should be multiplied by 2, okay, in order to get what the right answer is. Okay. All right, so if we do that, then and take g of x, then it would be 2 times the derivative of f of 2 of x. Okay, so a little bit easier if we see what's actually going on with in general. Okay, so what's happening in general, if we take functions f and g of x are both differentiable, then their composition is also differentiable. So I usually think of this as a nesting dolls. So whenever you're taking it, you want to take out the derivative outside, okay, the first one first, okay, and you want to leave whatever the composition is, um, that composition function, you want to leave it as is. And we will take a derivative of that in a minute and we'll multiply it. So we leave it as is, and then we'll multiply it times that composition. All right. So what is the derivative of composition of f of g of x? So if I have this, then in essence, what I'm saying is that this f of g of x is equal to e to the x cubed plus 4x. So how do I take the derivative of that? Well, I've got to take f of x first. So I want to take a derivative of my outside most part. Well, it's really this e. So what is the derivative of e? So that would be e to the whatever that power is, just x cubed plus 4x. So now I've taken the derivative of the e, but my other function, I haven't yet taken a derivative of it. So now I need to multiply it times the derivative of your exponent. So what is that? It's going to be 3x squared plus 4. And that's honestly how you do it. All right. So, and what we did is we just used the chain rule on that. All right. So what about this derivative function h of x, where we have ln of 5x minus 3? Well, that is actually a composition of two functions. So the first function is, in essence, if you want to think of it as f of x is equal to the ln of x. And then g of x is our other piece that's actually nested within that. So it would be 5x minus 3. So in essence, to get h prime, the first derivative, I'd use the chain rule. So what is that chain rule? Well, the derivative of ln is 1 over whatever's inside the parentheses of ln. So I've got f of 5x minus 3. And then I want to multiply it times the derivative of whatever's inside that g of x. So what's that? It would be 5. So you could have it as 5 over 5x minus 3. And that's honestly the first derivative. All right, using the chain rule. So now what I'd like y'all to do is try this one. Okay, so we are doing g of f. Now this is a little bit tricky, so it's g of f. So make sure you're getting it in the right spot. Press pause. All right, so just want to make sure that you've got it right. So the first step is to get g of x, we take yep, I got what I want. So it would be so it would be cosine of 4, and we're just plugging in 5x cubed. So this is really the cosine of 20x cubed. All right, so just want to make sure you got that. All right, so now I'll press pause and finish it out. If you did, so I'm just going to call this h of x. So h prime of x is equal to, and hopefully you got negative sine of 20x cubed. And we have to take a derivative inside. So derivative inside is going to be 60x squared. So this can be written as negative 60x squared times the sine of 20x cubed. Right? And that's should be the final answer on it. All right. Oh, and it matches there too. So that's a good sign. All right, so the quotient rule is consequence of product rule and chain rule, and this is honestly why I love this. Okay, this right here. So how do we make the connection? So if I take the product rule and the chain rule and use those, then I will actually get the quotient rule. So so let's say we have a function f of x over g of x can be written as product of f of x times 1 over g of x. Therefore, this, now I will say that I would write it as this, d of x of f of x, g of x, and that is actually to the negative 1 power. Okay, so this is what I want to do the product rule for. So if I do the product rule, I would actually get the derivative of the first function, f of x, times the second function, g of x to negative 1. Okay. Plus, now I take the derivative of f of x. I mean, not, I leave f of x as is. Don't want to take a derivative of that yet. And then I'm going to multiply it times the derivative of this. So I take out the negative 1 because that's my exponent of g of x. And now I need to subtract 1. So now it should be at negative 2. And then take a derivative of g of x. So g prime of x. So that equals, so I'm just going to rewrite some stuff, f prime of x. And I'm going to put this where it should go. So g of x is in the denominator because it has negative 1 power, plus I've, I got a negative. So I want to put the negative f of x g prime of x divided by g of x squared. Now, if you notice, I want a common denominator. So I need to multiply the first ratio by g of x divided by g of x. And if I have that, and I have terms g of x squared, and I would end up with f prime of x times g of x minus f of x g prime of x. And magically, that is the quotient rule. So it's pretty awesome. All right. So anyway, I hope that helps. And you have a great day and just giddy up.